Hello students. Now let's move on to next concept, change of variables. And here we have a theorem based on this. Suppose phi is strictly increasing continuous function that maps an interval a comma b onto closed interval small a comma b. Okay, and this is onto. Suppose alpha is monotonically increasing on closed interval AB and f belongs to R of alpha on closed interval AB, then define beta and g on closed interval AB by beta of y is equal to alpha of phi y and g of y is equal to f of phi y. Then g belongs to R of beta. And also we need to prove that integral a to b g d beta is equal to integral small a b f d alpha. So here we need to prove that g is also Riemann-Stieltje integrable with respect to beta. Okay, and also at last we need to prove that this integral is same as this integral. Okay, so now let's get into the proof and just make a note of this statement, or you can just take a screenshot out of it. Okay, so now we'll use this in the proof. Okay, so now let's get into the proof. Okay, see here they have given this phi. Suppose phi is strictly increasing continuous function that maps an interval a comma b onto closed interval a comma b, small a comma b. So capital A comma b to small a comma b. Okay, so we have taken a domain of phi as a comma b and codomain of phi as small a comma b, because they have given phi is a strictly increasing continuous function that maps an interval a comma b to small a comma b. Okay, so that mapping is onto. Onto means each and every element in the codomain has a pre-image in the domain. So that is the meaning of onto. And also, suppose alpha is monotonically increasing on closed interval AB, means alpha is monotonically increasing on closed interval AB means it's a real valued function. So here the domain of alpha will be closed interval small a comma b and the codomain will be real numbers, set of all real numbers. So whenever we tell that alpha is monotonically increasing on closed interval AB, then obviously the codomain will be real numbers. Okay, so here they have given alpha is monotonically increasing on closed interval AB and f belongs to R of alpha on closed interval AB, means this is also a real valued function. See here, this is mapped from closed interval small a comma b to R. Okay, it means that. And they have also defined beta and g on closed interval capital A comma b. So, if they have defined beta and g on closed interval a comma b, then obviously the codomain of beta and g will be real numbers. Okay, set of all real numbers. So here they have defined it as beta of y is equal to alpha of phi y. See here, consider an element y in the domain of phi. Okay, and since phi is a function, each and every element in its domain should have an image in codomain. So here, suppose y is mapped to x. Okay, and x can also be written as phi of y. Okay, means x is an image of y under the function phi. Okay, so I can also take this x as function of y, phi of y. Okay, and here g of y is defined as f of phi y. See, you need to understand this correctly because here, if beta is equal to alpha of phi y, then it will be this. See, the image of this under alpha will be the same as the image of y under beta. Okay, so I will once again repeat, the image of phi of y under alpha is same as the image of y under beta. So this is what they have defined, and also they have defined the image of phi y under the function f is same as the image of y under the function g. So this is also given in the theorem. Okay, see here, with this now we'll get into the proof. Okay, to each partition p, see here, there is a closed interval small a comma b, and for this we always take a partition. For this closed interval a comma b, we always take a partition p as x0, x1, etc. up to xn, where xn not equal to a and xn equal to b. Okay, so to each partition p equal to this of closed interval small a comma b, there corresponds another partition q in this interval. Why? Because see, if we take this x naught, then it will be here. Okay, it will be here in this interval a comma b. And since phi is onto, this x naught will have a image here in this closed interval a comma b. So if I take x naught here, then I will take y naught here, which is the pre-image of x naught. So here that implies xi is equal to phi of yi. Okay, that is x naught is phi y naught, x1 is phi of y1. So y naught is mapped to x naught, y1 is mapped to x1, y2 is mapped to x2, and etc. up to yn is mapped to xn under this function phi. Okay, now all partitions of closed interval a comma b are obtained in this way. So each and every partition whichever you take in closed interval small a comma b, there corresponds a partition in closed interval capital A comma b in this manner. Okay, so if you take x naught in p, then there corresponds y naught in q. Okay, such that phi of y naught will be equal to x naught. Okay, so this is how you get partitions for this interval capital A comma b. Okay, the value taken by f on closed interval xi minus 1 comma xi. See, this is the subinterval of closed interval small a comma b. Okay, the value taken by f on closed interval xi minus 1 comma xi are exactly the same as those taken by g on closed interval yi minus 1 comma yi. See here, so what they are telling is the image of phi of y under f is same as the image of y under g. So they are mapped to the same element. Okay, and it is the same with alpha and beta also. The image of phi y under alpha is same as the image of y under beta. So these two are mapped to the same element here in R. Okay, since the value taken by f on closed interval xi minus 1 comma xi are exactly the same as those taken by g on closed interval yi minus 1 comma yi, we have, see here, this is already given in the data, that is f of phi y. F of phi y means x. Okay, f of phi y is equal to g of y. That's already given in the data. So it's another form of expressing that. Okay, since the value taken by f on closed interval xi minus 1 comma xi are exactly the same as those taken by g on closed interval yi minus 1 comma yi, we have upper sum of g with respect to beta and with respect to the partition q is same as that of upper sum of f with respect to p and alpha. See why? Because this f of 5i, that is f of x or f of 5i is same as g of y. If f of x is same as g of y, then obviously the upper sum of f and g will be same. And similarly, the lower sum of g with respect to q and beta will be same as the lower sum of f with respect to p and alpha. Why is this? Because they have given f of 5i is equal to g of y. So obviously the upper sum of g will be same as the upper sum of f. Okay. So similarly L of g will be same as L of f. And we know that f belongs to R of alpha. This is also given in the statement itself. Since f belongs to R of alpha on closed interval AB, given epsilon positive we have by the condition of integrability, the difference between the upper sum and lower sum is less than epsilon. Since this is equal to upper sum of g and this is equal to lower sum of g, then upper sum of g minus lower sum of g is less than epsilon. Okay, and therefore g also belongs to R of beta. And also we can write integral a to b g d beta is equal to integral a to b f d alpha. Why? Because we have upper sum of f equal to upper sum of g. Lower sum of f is equal to lower sum of g. And what is this integral all about? If this is equal to its upper integral and this is equal to its lower integral, then we can write this as integral a to b f d alpha, or we can say f belongs to R of alpha. Okay. And here if g belongs to R of beta means integral a to b g d beta is equal to its upper integral as well as equal to lower integral. Okay. So we know that upper sum of g is equal to upper sum of f with respect to beta and alpha respectively. And also we know that lower sum of g equal to lower sum of f with respect to beta and alpha respectively. See, by this we can write integral a to b g d beta is equal to integral a to b f d alpha. Why? Because this is nothing but the infimum of all upper sums of g. And this is the infimum of all upper sums of f. And since upper sums are equal, obviously infimum of all upper sums of g will be equal to infimum of all upper sums of f. Okay, so we can write integral a to b g d beta is equal to integral a to b f d alpha. Thank you.